Hi everyone, and welcome to a single serving of Security Bytes. My name is Stefan, and today I'll be looking at the Hack-the-Box challenge called Gunship. In this challenge, we will be looking at why package management, safe coding, and small design considerations can make a very big security impact. The tools we will be using today will be Node.js. We will be using curl, which is a command line tool. It's very similar to Postman, and VS Code and Vim, as well as a browser. In this instance, I'll be using Firefox. If you are not familiar with any of these tools, please do go look them up. The documentation online is quite good for all of these. And then before we start, please don't attempt these techniques on any systems unless you have explicit permission to do so. This information is for educational purposes only. So to start off with this challenge, we need to download some files. It's in the format of a zip file. I've already downloaded and extracted these. If you are going to be attempting this on your own, you need to download this to your local machine. From here, from what we've extracted, we can see there's a couple of files in this directory. So first of all, there's a Docker file. If we open this up, if you're not familiar with Docker, this just says that we'll be running on Node version 12, and then it's installing some packages and moving files over. Nothing too special here. If we look at this config, there might be something in here that is useful. It's a supervisor D config. This doesn't really look useful to us. If we look in the challenge folder, we can see there is some code here. So this is the code that is running on the instance on Hack-the-Box. So they've given us this code so we can look through it and try to figure out how to exploit this. If we were doing this for a client, this would be a white box test because we have access to source control so we can actually see what's going on. Let's first look in this directory. We see a flag. If we open this flag, we'll see this is a fake flag for testing Hack-the-Box. So we would need to find this file in the challenge on the real server. This is not the correct value. If we close this up, let's look at the package.json, because there's usually info about the project in here. Let's see, it's called Gunship version 1. There's main index.js, which is here. It's got the basic scripts it's going to start. There is a dev. The tests don't do anything at this stage. If we look at the dependencies, there is something that stands out here, and that is that this package here, flat, it has an explicit version, and it's essentially locked at version 5. Now, if anybody happens to exploit number 5, or if there is something wrong with one of its dependencies, these will be included in our project always. If there was a caret or a tilde or some other kind of version here, then next time this built in the CI/CD pipeline or locally, it would have fetched the newer version, which would have hopefully fixed the security bug. So on that note, I'm going to do an npm install on this project so long, and then we can have a look for these versions, these 3 dependencies, if there are any known issues. So let's just run an npm install here. I'm in the wrong directory. Right, and while that's installing, so we're looking for express 4.17, flat 5, and pug 3. Any known exploits on these? So we can simply do a Google search npm express 4 exploits. And we get results. So from SNCC, there is some vulnerabilities. This is a very good place to look stuff up. So there are some vulnerabilities in here. We'll see there's a cross-site scripting vulnerability, but this is usually quite difficult to exploit the server side. This is more something that can happen on the client side, so this probably isn't what we are looking for. Let's try that flat package. We do see something that comes up over here in Sneak again for prototype pollution and flat. And we can see here this affects flat version greater than equals to 5, which is what we do have. We have version exactly 5 here. So let's read a bit about this. So it says here, flat is a take a nested JavaScript object and flatten it, or unflatten an object with delimited keys. Affected versions of this package are vulnerable to prototype pollution. Okay, that is a big problem. So there's a small proof of concept over here. So we just see they use unflatten in the code. And if there's an object over here, we can pollute the prototype. Let's see here. Okay, so this is just an explanation about what prototype pollution is. So in a nutshell, prototype pollution is when we provide something to the code that overrides the base object class in JavaScript. Now, every object created in JavaScript follows a template or a prototype. And if we can get stuff onto that base object, then every other object in the code will have it unless it's explicitly overwritten. So now we know what this is. We don't know if this project is vulnerable to prototype pollution. So we know it's got a vulnerable library, but it needs to be using it in a specific way for us to be able to exploit it. So let's go back to the code. I see we're still running an npm install. I'm going to close this quickly. I'm going to open this in VS Code. This over here. See this challenge. So we've got the package JSON, which we've looked through. Then we've got the static folder and the roots folder. So this looks like a fairly standard project structure. Let's go to the index.js. Let's see. It's including express, roots, and this path library. It's setting its views up. It's setting up a static directory for the static content. It's using the roots, and for everything else, it says 404 page not found. Something to note here, the service is listening on port 1337. So if we start this up locally, we would need to add port 1337 either in browser or in curl when we talk to the service. All right, so let's see which roots are available. If we look in index.js, we'll see there's the base root, which sends this file, views index.html. All right, so let's look at views index.html. Okay, it looks like some static content is here. I think let's wait for the install. Let's boot the server up and then see what this page is. And now that that's done installing, we can also see there is a warning here. Flat 5 has been deprecated. They fixed a prototype pollution security issue, and we should please upgrade. Okay, I'm going to run this. It says it's listening on port 1337. Okay, so in the browser, let's go to localhost 1337. Okay, so this looks like a nice site. Gunship is a British synthwave band formed in 2010. Very nice. Okay, then who's your favorite artist? Okay, there's an input here. It does look like that's the only way that we can interact with the page, apart from this one link that goes external, so we're not going to follow that now. I'm going to open up the DevTools for Firefox and go to the Network tab. And let's just see what this is doing. If I send random data, it says, please provide us with the full name of an existing member. request response, we see the artist.name was sent, and in response, it sent us this message. Okay. Now let's see if we can find this in the code. So this was sent to API submit. So if we go here, back to the roots, we'll see that is the next root that is in this file. I think that's actually the only other root available in this challenge. Okay, so on this API submit, what is it doing? And then we immediately see the first line. It's running unflatten, which is what was warned about in the recommendation from SNCC. If you see unflatten, there is a chance that prototype illusion can be done. Okay, so we have to remember this part. And there's an if statement over here. It checks if the artist name, which is the property that we saw being sent through, includes one of these three names. I'm not very good at pronunciation, but I think it's Hey, Westaway, and Ginjal. If it's one of those, we return this response over here, which is pug.compile. I'm assuming this is a templating engine. It says span hello user. Thank you for letting us know. And the user is set to guest, hard-coded. If it's not one of those, it returns the response. Please provide us with the full name of an existing member, which is the message we saw. Okay, so I'm going to copy out this name. Then do that in the browser. Let's see the response change. It says, hello guest, thank you for letting us know. So we are hitting that endpoint, and now we've hit the good case for that if statement. So from here, we need to see if we can exploit this, if we can get this API submit endpoint to do something that we wanted to do and not necessarily what was specified here in the code. So the first thing I'm going to do is I'm going to open up another terminal, and I'm just going to construct a curl request to this API submit endpoint. So this will be a JSON object. It will say content type application JSON, and you can copy this entire thing from the browser as a curl, but it's good to know how to construct these manually as well. So this is a post request. So we'll be doing post request, and then we need to give it some data. So the data that was sent over here was artist.name. So we'll do a JSON object artist.name, and the value would be hey. Right, and we see in the response, hello guest, thank you for letting us know, which is the response shown over here. Now there are many ways to test for prototype illusion, but one of the things we can do is try and overwrite this user property over here in some way or another. So let's take the same object, but we're going to add a section called proto, and we want to overwrite the user, and instead of guest we want to say I am injected user. If we run that, we'll see it's still guest. Nothing really happens after that. We can, however, go look at this documentation for Pug, or API reference. Let's see if there's some other objects we can pass instead of user that can tell us if this injection is working or not. Right, so if we see pug.render, but we're using pug.compile, it's this method over here. It takes a source and then an optional options. So pug.compile, optional options here. Okay, so if the options is not present, which is it isn't in this case. It is. No, okay, sorry. The options would have been here. Then it'll use the default object or a new object, which is essentially just the two braces. But on this object, there's a bunch of hidden stuff which is part of the prototype, and that is what we are messing with here. So if we set one of these, let's set debug. If we set debug, let's see what it does. So I'll add another field here, proto.debug, and this is a JSON object, so we can use little true. It still says hello guest. Something interesting happened now where we were actually running the npm run start. We can see that there's this compiled function dump over here. And this shows the template function from Pug with the locals it had at the time and the string it is using. So we've actually turned on debugging on the server with this prototype solution. So let's see what else we can do. We can set this globals, which is add a list of global names to make accessible in templates. Okay, so if we set the globals in addition to debug, just to see what we are doing. Globals, which is an array of string. Array. Let's use the global user instead of the one provided in this object to the function. And if we run that, we'll see it returns, hello, I am injected user. Thank you for letting us know. So with this prototype solution, we've actually been able to get into a completely unrelated library that isn't vulnerable as far as we know, and overwrite something in the code that was static and change the response coming back to the user. So that's why prototype pollution is very, very dangerous if it can be exploited in your code. So now the actual exploit for this specific service is quite a bit involved. And unless you've read through and gone through the source code of Pug and actually know what is available to exploit, or you have some understanding about how these template engines normally work, it's going to take a while to go through all that, and it's not really in the scope of this video. So I have prepared a call request that we can use to demo this locally, and we will be making the links available. So just to show you the link, the exploit specifically we will be using is AST injection prototype pollution to RCE. So RCE is remote code execution, which means running something remotely or on the server. And then the AST is the abstract syntax tree, which is used in some templating engines. One of them would be Handlebars, another one would be Pug, but there are many templating engines available. So from here, we'll be doing a quick proof of concept locally. So we've got a call here that essentially does the same. It sets the artist name, and then there's this prototype we're polluting over here. This is something internal to Pug that we're overwriting. So we are making it execute another block of code that we want. So that block of code specifically is going to require child process and exec sync. And then we're going to run a command. So the command we're running is doing a cat on etc password. So etc password is a special Unix file which contains all the local users and groups. Cat just means read the file. It's similar to type on Windows. And then we'll be taking that content and putting it in a static images out.txt. So we'll be able to, in a browser, see what the content of that file was. So if we run it, it says, hello, I am injected user undefined, right? So it's still got the old object in there. Okay, now if we go to static images out.txt on the server, let's close this up. We can actually see we have dumped the etc password file. So the one we're specifically looking for in this challenge is actually the flag. So let's do a cat on the flag on local. And if we refresh this, we'll see it is the fake flag for testing, which is the flag over here in this folder. So now we'll be running it on the actual instance. So we can all see that there are no local shenanigans going on. If we see we've got this host and this port now, so we'll copy that out. So if we take the command that we've built up, let's change the curl host name and port over there. We are going to not take the flag right now. Let's do etc password again. Going to static images out.txt. It says, hello guest undefined. Thank you for letting us know. And if we go to this address, we'll see it is the gunship. And we'll go to static images out.txt. And we can see the users of the remote machine. Now, as you can see, one of the risks in prototype pollution is data leakage. Anyone who can exploit this and get remote code execution can get any data of that server that they have read access to. There's also an issue of defacement or hijacking the code, where if they can do something like this, they can maybe read the source and then overwrite stuff in strategic places to hide themselves and to take malicious actions against the users of the service. There is also the possibility of a persistent threat if they are able to get a shell or add something to the service which connects to something externally every time it starts up, that would be able to execute commands from that service. They are generally more difficult to detect, and even if you restart the service many times, because of the access they have, it'll just reconnect and continue executing its malware. So let's discuss, how do we stop this from happening? Well, the first thing we need to do is make sure that there are no vulnerabilities in our dependencies or in any of their dependencies. And if there are, we need to be very aware of them and how they are exploited and how we should mitigate against them. So if we had, instead of this explicit version here, if we had a careted this or a tilted version, we would have automatically gotten a security upgrade and we would not have been vulnerable. The second thing that could have been done is in the roots folder over here, or the roots file, we only really need to code for what we need at this stage, and we shouldn't trust user input. So in this section over here, where it unflattens the rec.body, it's actually only looking for artist.name. It's not looking for everything else that comes with this object. So instead of unflattening this entire body, just take the one field that we do need and sanitize that, and then we can check if the value is what we're looking for. And while this might be a contrived example, there is a recommendation we can also make. Because this code is very simple, actually, it's just checking for a value that is exposed on the client side. Let's just go back there. We are typing in something here, and then it's sending it to the server, and it's doing a very basic check and then responding to it. This entire block of code can actually live on the client side. There's no reason to send it to the server, so nothing actually has to come to the server to do it here. If it was over here, then this exploit also would not have been possible, and the behavior could have been the same. If they said either hey or westaway, then add the message there, very simple JavaScript, and it makes the server-side code a lot simpler. Well, that is it for today's single serving. I hope you have enjoyed it, and we hope you have learned something. Again, please don't attempt these techniques on any systems unless you have explicit permission to do so. This is for informational purposes only. Thanks for watching.